Okay, hello everybody. Hi, Porco. Let me, I think you're muted still. Let me unmute you. Can you unmute yourself?
Yeah, how are
All
you?
right. Hey, good. How are you doing?
Well, we had just coming off a big week at KubeCon. It was, crazy madness, but super fun as always.
Oh, so good and so exhausting, right?
Yeah.
Such a good time to see everyone and hear about all the new things that are coming out in the world of cloud native. But man, those are long days and long nights as well.
Yeah, it was, but it was an amazing week, at least. And not only just for cloud native, but also for the subject at hand. We also had really nice conversations around supply chain security topics. Both Stacy and me were at the Sixer booth at the KubeCon main floor and also at SixerCon. So lots to talk about. But yeah, you want to do some short introduction, Stacy,
Yeah.
before we start?
Sounds good. All right. Well, welcome everybody. Welcome to StackLock's user group meeting for November 19th, 2024. I'm Stacy Potter, an open source community manager here at StackLock, and I'm joined by my colleague Porco. And we'll be joined in a few minutes by Ian, Jonathan, and Allen, who are all maintainers of the OpenSSF project bomctl, and also part of Lockheed Martin's open source team. And they're going to discuss the wide world of SBOMs. So I hope you're in the right spot, and thanks for being here and joining us today. So just before we kick things off, I wanted to give a quick bit of housekeeping and introduce the company that Adolfo and I work for. So we've allocated an hour for this session, and if you have questions at any time, feel free to put them in the chat and we'll be sure to get to them. As I mentioned before, we work at StackLock. Hopefully you've heard of us, but if you haven't, we are passionate about making software, open source software, safer. So our team's background is in creating, maintaining, and scaling open source systems, including Kubernetes, SigStore, and many others. We're drawing on our expertise in open source and security to give developers and open source communities better tools to secure their software and manage external dependency risk. We believe that contributing to open source is a necessary part of everyday work, and as part of their daily tasks, our company leaders, engineers, and PMs build, maintain, and contribute to open source projects and lead open source initiatives that support upstream communities and advance open source security. To learn more about who we are and what we do, you can visit stacklock.com, connect with us on our Discord server, and subscribe to our YouTube channel, where you'll get notified when our upcoming Securi-Taco Tuesday live streams are scheduled, like this one, and join our StackLock user group meeting. So it is that time of the presentation. It's taco time. So let's talk about it. Puerco, what is the taco of the day?
Well, the taco of the day is the taco al pastor, which I guess roughly translates to shepherd style taco, maybe, which is misleading because al pastor tacos are made out of pork. You will often see them being cooked as part of a big kind of mass that's put directly to the fire. And they are always served with a little bit of cilantro, onion, and pineapple. So al pastor tacos are prepared with pineapple and a special ingredient that we'll talk about. I got mine from my family taco shop that we go every other weekend, maybe, which is like 3 blocks around my house. And this is an actual picture of the tacos I got this morning for the show.
Nice. I live in upstate New York, so I don't have access to a lot of good Mexican food or taquerias. However, there is one place up here that I absolutely love. It's called Azul. It's in the background picture there. And I actually found out, I talked to the owner today when I went and got my tacos for lunch, that she actually lives or came from the same place where Puerco currently lives. So she is from Mexico City in your hood, man. And I don't even like pineapple. And so I got these pastor. I don't think I've ordered pastor tacos before, actually. And I didn't know that they were pork before. I thought they were like more like carne asada or something. But they were delicious. And oh my God, the grilled pineapple on there just made them. Like
Yeah,
that little
exactly.
bit of
Don't
sweet.
don't ever confuse this with the taste of pineapple on pizza. That is a no-go.
No, yeah,
This one,
I agree.
yeah.
Don't add us, okay? Don't come at us because we don't like pineapple on pizza. But I will say the pineapple on the taco really gave it some extra flavor. So anyway, thanks for getting your tacos. I thoroughly enjoyed my El Pastor tacos today with my horchata. And that is
Yeah.
a picture overlooking my backyard.
Yeah, on the next slide, we
So,
have some pictures of how they're actually served. Like you see
yeah.
the taquero, and they usually, it's pretty amazing to watch them work. They will slice through the pork and then just do like a machete chop on the pineapple and catch it with the tortilla on the other hand. Amazing stuff. But
Nice.
yeah, but one of the things that it's interesting about Al Pastor tacos is their orange color. The orange color comes from a plant called achiote, which is in the next slide. So it's a seed. So this is like a small tree that blooms, and then inside of it are these pinkish reddish seeds, and the smell of it is delicious. And achiote powers most of the great dishes of Mexican cuisine, such as not only el pastor but cochinita pibil and the michotes. Oh, michotes is a new one, a good candidate for the next one. But sometimes if you go to cheaper places, you'll find that not all tacos al pastor are made with real achiote. Sometimes there's a chemical replacement on the next slide, which is, I don't know, it's red dye that people put into the, and it's, I've heard from friends of mine that work in the taco industry, if that is a thing, that this stuff can actually make you sick. So like if used improperly, so you would want to avoid that. So Stacy, how do you know if your taco has achiote or has, orange pea in it?
I mean, I guess that's a really good question. How would you know? I don't know that I would know.
Exactly. If we only could get the equivalent to our subject today, like a taco bill of materials. So I know most of the SBOM whatever are taken. I'm claiming the taco bill of materials as a creation of this show. So
Nice.
I'll start working on the tooling and, of course, some standards to go with it. But well, anyway, so this brings us to our subject today, the software bill of materials. We have some of the folks working on some of the most interesting ideas around SBOM and the bill of materials at large. So, should we bring our guests into the call?
Let's bring them onto the stage. I'm going to get you all up here, and then you can do a little round of introductions. So, Ian, Jonathan, and Allen, welcome to Securi-Taco Tuesdays. Thanks so much for joining us.
Thanks for having us,
everyone.
Yeah. So Ian, do you want to, I guess, introduce yourself and then kick it over to your team members, and then we can get some introductions here?
Yeah, Ian Dunbar-Hall. I feel like I do a lot in SBOMs, but you always meet new people every day. So yeah, I do a lot of work through OpenSSF, where I'm a governing board member, and then I also do a lot of work through the CISA SBOM communities. In general, I think like everyone who works in the public sector, SBOMs are front and center right now if you have the US government as a customer. And then especially in Europe with the CRA coming in, right? There's a lot of requirements that people are not thinking through. So that's a big part of what I've been focused on and what I'm thinking through. I'll turn it over to Allen Shearin. You want to introduce yourself?
Hello, I am Allen. I am a member of the open source ecosystem team at Lockheed Martin. I've had the pleasure of working on a couple projects related to software security, namely Hopper, Scorecard. Obviously, bomctl is front and foremost on that one, but happy to be here. Jonathan?
Hey, glad to be here. I'm Jonathan Howard. I'm the tech lead for the Lockheed Martin open source ecosystem and secure software supply chain teams. I'm also a maintainer on bomctl and protobom. They pair very well together. Yeah, and I'm just a guy with a background in software development, infrastructure as code, cybersecurity, all that kind of stuff. Yeah, it's exciting times we're in. Happy to be here. Thanks.
Awesome.
Amazing. I mean, I think there are few teams out there that really get the value of the stuff that we're working on, as this gentleman here. So I don't know, does anybody want to do like a super brief, explanation of what an SBOM is, what it's good for, some of the use cases? I mean, starting with what it is.
Sure, I'll jump on that one. So we often talk about SBOMs to folks who are just learning about them as kind of like the list of ingredients on the back of a food label, right? It lists out just the basic ingredients, maybe what proportion they are of that, and some of that initial pedigree of like what you can find inside this product. And so I think if you look at use cases, like why are SBOMs important? Why do they matter, right? And I think we'll have some slides up in a little bit talking to that. But today, software is like one of the few things you buy where you don't really know what's inside of it. Like it genuinely is a black box. And so we talk about software materials as a way to have visibility into what you were purchasing. Like, can you imagine a car where you couldn't open the front hood? Like, that's kind of the scenario we're in today. Like, and you can't really poke around and see how things are made. And so I think there's a lot of value in SBOMs just purely based on knowing what you have when you purchase something. The same is true for open source too. When you consume open source, it's important to know what's inside of it. And there's reasons for that, right? Like clearly, like vulnerability information is front and center for a lot of folks, right? How do we quickly triage when new vulnerabilities are disclosed? How do you as an end user figure out when when patching may be required? And I think the other big use case, especially at an enterprise level, but I think also for anyone who is trying to take open source software, combine it with other things to make new products, what does the licensing of all that stuff look like? You throw it out there today, like on average, over 70% of enterprise software that's delivered to a customer is open source software, right? And I think it's humbling to think about the value that open source provides. And I think it's also really good to have that acknowledgement of what open source has brought to your product when you go present it to a customer. Like it's very important to be able to portray the value that greater open source community has delivered that you've built on top of. So that's really the value of open source, or value of SBOMs, is helping portray open source software, helping you with the licensing, and also helping you with the vulnerability management.
Any Allen, Jonathan, you want to add more color to that?
I think I'll probably reiterate a lot of it, but especially for larger companies and with products that you buy, like the software, with like the advantage of open source is that you can look in the repository, see everything that's in there. You can kind of know what you're running, know what you're looking at. But if you buy, if it's an iPhone, or not to single out Apple, but like any kind of product that you get that has a bunch of, embedded technology as well as a bunch of software built on top of it, what does that look like? What is your, attack surface in terms of your privacy? Like you don't really know any of these things. And obviously the privacy or information disclosure that every company has you sign when you sign up for a software or an app, nobody reads that. So it's important to know what your vulnerability is if you're building a software product and you're trying to release it to customers. You want that transparency to say, hey, I've done my due diligence, but also the customer, or if you're consuming software, you want to know what your attack surface is in terms of vulnerabilities and just what you even have when you're accepting that dependency or accepting that product. What are you taking in? What does it look like? So I think it's very important.
Yeah, I also sometimes tend to think as SBOM as the token of exchange among a lot of the supply chain technologies out there. Like, for example, you mentioned the vulnerability. So when you have a vulnerability scan, it should ideally be tied back to a specific hashed artifact or commit or whatever. But then if you want to explode that and understand what's in that, that's where the SBOM comes in. If you have a provenance attestation, what is the end result of that process that gave you an artifact? Well, the description of that is in the subject. So I tend to think about it as the kind of the stuff that binds the supply chain galaxy together, because everything seems to have at least one connector tied to SBOMs. Yeah, but it's great. So we've been working. I mean, and when I say we, there is a lot of people that have been thinking and working, having opinions on SBOM, like for, I don't know, a good over half a decade now, maybe more. So some of the, I think that we're starting to move past the initial. So I think there was an initial date where we were trying to ideate what an SBOM was, then trying to agree on kind of the standards and how we do them in some of the initial tooling to generate them. And I feel we're entering a new phase of actually making SBOMs useful. I don't know if you agree with me. You're, of course, working on pretty much most of the most advanced use cases for SBOM, but I don't know if that if you also shared that feeling that we're moving into this new. So before, just we're past the okay, I have an SBOM checkbox, and now moving into the okay, I have an SBOM. What can I do with it? Is it high quality? All of that.
It's kind of like a SBOM renaissance going on right now.
Maybe, yeah, it could be.
Yeah, I think there's a lot of, your boss or the U.S. government or someone says you have to be generating an SBOM, and then you click the box, you say okay, the CI/CD is in there, it's making it automatically. All right, I'm done. We don't need to do anything else with it, and that's I think where a lot of people are now, and it's kind of like the question of what should be in an SBOM is mostly solved. I think there's some disagreements there, obviously, but I think for the most part we're generating them consistently where we should be. And then to your point, Berko, like we're getting to the point of, okay, now I have all these SBOMs for, my software and my dependencies, and how do I get them to my customer? What value do they provide me?
Right. And also it also opens other questions like how do I trust the data and the SBOM, but we'll get to that. So what do you think are the current challenges? So before we used to discuss for hours things like, oh, how do I get this SBOM to be NTIA compliant, which is still a problem and a challenge for some projects, but I feel we're running into newer challenges which are more interesting and that we need to solve to keep adoption going. So what do you think are the most pressing ones?
For me, I like the analogy of an SBOM being sort of a list of ingredients of what's in your software. For each of those ingredients, what's in that ingredient, what's in that software, and then so on and so forth down the chain, and that can create sort of a dependency path structure kind of thing, and it turns out to kind of look like a graph, and that's one of the things that's coming up a lot lately. And how do we manage that graph? How do we associate things and make sure that those relationships are maintained? So that's one of the big challenges I think that we're facing, and hopefully facing head on, trying to deal with effectively.
Yeah, exactly. I was just chatting last week with one of my colleagues about when we started working on the first tooling for the Kubernetes SBOM, which is pretty large. We had a demo of the SBOM in tree form. And then some of the tech leads in SIG release were like, you know what? We have a lot of tooling inside of the company they were working back then. And most of it we'll prefer if you have a flat list of dependencies. So can we flatten it? And I was like, well, okay, sure. I mean, we were still exploring what an SBOM was and all of that. So from that day, it was 4 or 5 years ago, until this day, the Kubernetes SBOM is flat. So if you download, it's just a flat list of dependencies. I feel that we've uncovered several use cases where the actual tree or graph is more useful and also much more interesting to manage.
Much more digestible too. Looking at a 30,000 line file is not really helpful, but if you see the relationship between everything, like Jonathan was saying, it's a lot more valuable.
But
Yeah,
in that
exactly.
flat list, if you have, two of your ingredients both depend on the same underlying dependency, how many times is it represented in that flat list? And which is the parent, which is the child? Do we lose those relationships by flattening it?
Yeah, we just recently had that conversation in one of the OpenSSF channel, and it's a very interesting one. Like, if I'm listing the same component twice in an SBOM, is it wrong? Is it right? I don't know. What
Are
do you
they
think?
the same?
Are they the same? Exactly. I mean,
And how do you tell?
exactly. I mean, for that, we should have hashes and identifiers, which also are both, well, hashes not that so, but identifiers can sometimes be its own kind of worms. But I feel we have the tools to identify them. What do you think?
I mean, yeah, absolutely. If the hashes are included, I don't think that they're explicitly required. There may need to be other ways of checking if one component or one package is equal to another based on a certain set of, hate to say it, but opinionated rules.
Yeah.
I think
One
the
of the
challenge
things.
there
Oh,
would
go.
be, I think one of the challenges though is like a lot of secure hashes are ecosystem dependent. And so like take Python, for instance, like you have a secure hash, but it doesn't tell you, is it the real file? Is it like on disk? Is it like, what is it? And so even within that situation, we often do look at like secure hashes as like a good apples to apples comparison to the test identity. It's still can be a little nebulous. And I think that's an area of ambiguity right now when we talk about SBOMs.
Yeah, that was going to be exactly the same point. I remember one of the SPDX, or maybe not not just one, but one of the SPDX Dogfests. Everybody was generating SBOMs for packages, and all of the hashes were different. And the conclusion was, it's not that they were wrong. I mean, some of them were hashing the wrong thing, but I mean, wrong in the sense that sometimes it was like an empty file or just a file or whatever. But some people took a tarball or a manifest, or I mean, different approaches to the same thing. So yeah, it's I don't know, it's an interesting problem. By the way, this is supposed to be like an introduction to people who are not very familiar in the subject. So Stacy, if we're nerding out too deep, I mean, please chime in. All right. Okay, so basically SBOM, the list of ingredients of your file. There are other. So do you want to talk a little bit about how regulation is driving and shaping some of the SBOM developments? I think that's a very important part of the whole SBOM sphere.
Sure, I'll jump on that part. So yeah, I think for us with our employer, like we were using SBOMs internally, but it was more for internal compliance. We had not really thought about it as like a deliverable that we were giving to our customers. And I think there's kind of like some really good work really through, I'll say CISA, but in partnership with a lot of other governments across the world. We're beginning to see a lot of regulation coming out. So CRA, I think, is going to be very eye-opening for a lot of folks when they start reading into the requirements there. And there's going to be some very specific requirements about what this document looks like and what you need to include in it and what you need to exclude from it also. So I know Porco, if you haven't read it yet, it's going to make you happy to hear like an SBOM under CRA that has vulnerability information in it is not a valid SBOM. They very explicitly call that out. Like I think that's great, but it shows you like there's going to be some very specific wording that people are going to have to be being cognizant of. And then I think in our world, predominantly working with the U.S. government. There was an executive order that came out a couple of years ago that basically said, hey, how do we better secure the open source ecosystem and the software that's ultimately used by the federal government in the US? And we talked about SBOMs, and I hate to say it, like SBOMs are a bit of the molehill with a larger secure software supply chain process that's going to have to happen following up to that, but it's a good first start. And it's been a little bit of like a hurry up and wait. We kind of see like, a tsunami is going to come. the water recedes, right? And like you kind of see everything laid bare, and you kind of look around, you're like, oh, gee, this is not good, right? And you see the wave off in the distance, and you see it coming towards you. And a lot of people are still looking like inland, like enjoying the nice view, and you're like might be the only person turned around. And we're at the phase now over like, I'd say maybe like the last 6 months, that I feel like the crowd is beginning to shift around, and everyone sees this impending wave. And it's so big that we don't know exactly how far away it is. But in our specific instance, right, as like more working within the defense industrial base, the DIB partners, you know, we are beginning to see folks like the Army very strongly roll out SBOM requirements, and like any new federal contracts within the Army starting in February have like very stringent SBOM requirements. We see it in the past already with like FDA. We've seen it with NASA. We're beginning to see all parts of the federal ecosystem, not just defense, but all agencies roll out these requirements. And the thing that I think is not talked about is that, yes, we might be I'll say the primary contractor, the primary entity that's delivering the software. People don't quite realize how deep our supply chains go. And you could easily be a dependency in that supply chain. And therefore you may quickly find yourself getting asked for an SBOM, even though, like, yeah, I don't really work with the federal government. I don't, you know, but you may be in part of that supply chain, and you may find yourself getting a request for an SBOM. And it's going to probably impact your business. Like, you may not be selected. And so it's something today to start thinking about. Is the amount of effort to do it is not big, but it's going to start really affecting how much business you are going to be able to do, even if you don't directly relate to the U.S. federal government. As part of the supply chain, you may be consumed by the federal government without even knowing it. And you should be prepared today to meet these requirements, specifically around SBOMs. And today, the minimum elements, which will probably get revamped a little bit over the next couple of months.
So, Ian, I'm curious to know. So you say, like, even if you think that you're not doing business with the federal government, you might still be doing business, or someone who requests an SBOM, because
Sure.
you're part of this puzzle piece of chain. Your supplier's supplier is your supplier, right? That kind of thing that you're going to be pulled in, maybe not even knowingly being a part of this certain supply chain.
Yeah, I mean, we talk a lot about open source security, and we talk a lot about open source supply chains, right? And like, there's you as a maintainer on an open source project, you don't necessarily know where it's all used.
Right.
And I think that's especially true for a lot of small mom and pop software publishers too. You may not know where things are getting included. And sometimes, right, based on the sensitivity of the environment, you may not ever find out about it. But you certainly are going to be asked for an SBOM, and you may not know why it's happening that you're getting this request. So it's interesting to think about. You know, the U.S. federal government is like one of the largest employers in our country, at least, and it is one of the largest consumers of software in the U.S. And so it's a huge market. And you are probably part of that market if you are delivering software to anyone.
Yeah, and this is why it makes so much sense that we're working on these problems together. I feel that part of the problems with SBOM adoption has been sometimes vendors working siloed to get SBOMs to work in a very specific niche use case in their projects, but there's also this huge community of people trying to solve those problems out in the open. And I would like to especially call out, the folks working on CISA, Allen and Victoria and all of them. Like, they're doing such a magnificent job, like just rallying and organizing people in different interest groups. It's been magnificent. I actually have my official old style SBOM sticker and the new one, which is I don't know. I've been so thankful for how much they've enabled, and a large player in that is, of course, the OpenSSF and the work that we and then this time I mean some of us in this call are doing to work on the SBOM tooling, which brings us to especially bomctl, which solves very on-point problems that people have with working with SBOMs today. So I don't know who wants to go and open it up to talk about bomctl.
I can take it. It's
go ahead.
So bomctl kind of is the answer when someone asks, okay, what do I do with it? I guess it's part of the answer, really. They generate an SBOM. They have that checked off on the CI/CD list. They, their QA control, whoever's asking for the SBOM, they're satisfied with what they're generating. But then bomctl is something that facilitates movement to the next step, whether it's delivering it to your customer or ingesting stuff from your supplier. So basically, it bridges the gap between generation and analysis tools. So if you have a registry you want to go to or anything like that, so it's basically built for managing SBOMs and trees of SBOMs, systems of SBOMs, SBOMs that describe large software platforms. And it facilitates the movement from one place to the other. And that sounds pretty simple, but we'll get a little bit more into it. Jonathan, I don't know if you want to add anything to that.
Yeah, sure. So bomctl is meant to be sort of a format agnostic solution for managing and storing all the SBOMs in a dependency chain or supply chain or what have you. And we just wanted to have a tool that solves a lot of the problems in one place. Things like merging SBOMs or diffing them, comparing one versus another. And yeah, all of that is backed by protobom and SQLite database under the hood.
One of the things that we probably should have talked about before going into bomctl is that the fact that there are two main standards of SBOM, both TACLONDX and SPDX, and they both do the job of capturing the structure and the dependency information of your software project. And so one of the big goals that we have today across the OpenSSF projects is trying to come up with tooling that works equally well with any of them. So that's kind of the format agnostic spirit of the project. Do you want to talk about some of the capabilities? What can I do with bomctl today? Where do I get it? All of that.
Sure. So Stacey put the link to the organization on the screen there, I saw. But some of the things that bomctl can currently do, it can fetch SBOMs from remote locations. And right now we're supporting Git repositories, OCI registries, and just plain old HTTP fetching. In addition to that, it can import from the local file system. As probably mentioned, if you're familiar with Docker, it should feel fairly familiar to work with bomctl because a lot of the operations are analogous. And that was kind of the point. I wanted it to feel familiar for folks. So aside from fetching, importing, you can also do push. So that's supporting OCI registries and Git repositories at the moment. We have work underway for supporting GitHub. So we have a GitHub client in the works and a GitLab client in the works. So that'll support fetching and pushing as well. What else?
Is it helpful if I share some of the slides so that you can talk to them?
Yeah, most definitely.
Are these the right ones?
Yeah, absolutely.
Cool.
This is going over the commands that Jonathan was just talking about, but go ahead.
Oops.
Yep. So export, that's the same thing as, well, that's the opposite of import, right? So that'll take a SBOM that is currently stored in the bomctl database and write it out to the file system. And yeah, you got list. That's just tabular output of all the SBOMs that are currently stored in the database. And we also have some sort of, I don't know, call them metadata operations. Internally, we call them annotations, but that'll support things like alias and tags, where alias is unique to a particular document in the database. And tags can be anything, just arbitrary keys, values, that kind of thing. And we have an initial implementation of merge that works pretty well. So those are just some of the things that bomctl can currently do.
How much, I mean, I'll say, like, why are we talking about these specific things? I think it's pretty relevant. So, you know, there was just a discussion around dependency trees, right? And we then talked about suppliers, right? And the dependency between suppliers. And so if we talk through that, right? Well, when multiple suppliers are each releasing their own SBOM, we effectively begin to get a dependency tree of SBOMs that then have dependency trees, right? And a lot of how we talk about SBOMs today is more like as singular documents, right? Hey, I'm releasing an SBOM for this product. You know, like the Windows SBOM is what, like 135 gigabytes. Like, the reality is like we don't really want to treat these SBOM documents the way it's been kind of going, which is, hey, if I have, I don't know, some dependencies in Python, right? Like the idea that I need to deliver all of my dependencies as part of my wheel file in Python, right? So I've embedded all the other packages inside of it and I ship it across. Like, that's not how we've structured everything else, but it's kind of how we talk about SBOMs today. We create a singular document that has all the dependencies and we ship this one thing monolith across. And so, like, let's start talking about SBOMs more as like relationships between those documents, right? So we talk about vehicles. It could be, you know, car. It could be an airplane. It could be anything, right? But ultimately, it's a system that has a whole bunch of subcomponents that have components below it, right? And so, how do we build tree structures or hierarchical relationships between that? And so, like we have on the screen is like a really simplified example, but I think it really illustrates the point. Like, what does a SBOM for a Helm chart look like? Well, you probably have a top level like Helm chart that has like a Git repository, and that could be a dependency. And then you have a couple container images that are dependencies. But that one of those container images is probably made up of a sub dependency on maybe a base image that you've added an application to, right? So in this situation, you begin to get these different SBOMs, thinking down the road where, like, you know, Docker Hub has announced that they're going to release SBOMs for all their official images, right? Well, gee, we should respect that SBOM. We shouldn't recreate it as part of our document. Let's go ahead and have that as an external reference. Hey, and then, like, let's look at maybe there's, you know, a graduated project in the CNCF, and they've released an SBOM for the Go binary. Let's reference that. Let's not recreate that information, right? So we begin to get this tree structure where we have effectively, like, I'll say downstream, but like leaf nodes on a dependency graph that are SBOM documents. And how do we begin to build that up? And it adds complexity in the management. So a lot of what Jonathan just talked about, like, hey, we'll be able to, what we do today, you could pull a top level Helm chart SBOM and recursively go through all of these dependencies and then find all the sub SBOMs, one from Docker Hub with maybe OCI, you might be getting something from GitHub release. Like, we can fetch that entire set of documents through recursive search, and then allows you to begin to analyze it locally. So when we talk about that separation between like generation to analysis, is, well, how do you actually get this stuff? Like, how do I download it, especially if it's a tree structure, and I put it someplace? And then how do I analyze it on that system? And when I'm done analyzing it, where do I put that tree structure down the road, right? How do I move things? So it's really important what Jonathan was just talking about as a way of finding, separating out, you know, and having a little bit more like those dry principles that we always talk about, right? Like, you should really treat an SBOM from a supplier as the provenance, the pedigree, where you don't want to mess with it. You should leave it as is.
Yeah, I really see bomctl as the tool that allows you to kind of gather things as a tree structure, but also build a tree structure. If you're given, you know, from your suppliers, you're given an SBOM in any format, either one of the formats, and you have your own things to add to it, whether it's, you know, a container image or your own, obviously your own bill of materials for your software that you wrote. It lets you create those links, and that's a feature we're working on right now. So linking together these SBOMs and saying, okay, so I know exactly how these things link together or how they should link together. And I know the components in my product, and I can point to, say, container image SBOM for that component, and you can build a tree yourself and then, export it to your customers or your users to be able to ingest that later in exactly the way that Ian was describing and Jonathan was describing, where you can just, fetch that one top level document and then it ends up pulling everything. So it not only lets you kind of move these trees back and forth, but it also lets you build them yourself, which I think is very important.
Yeah, that's a very important point. I really like that phrase that you all started using lately, that bomctl breaches generation and analysis, because it's, going back to the example of the Kubernetes SBOM. So during those days, we chose to flatten the dependency tree because it was what tools were expecting. But with bomctl, I feel that we now have the capability to, have ingest the highest quality data that we can, and it can be even from multiple sources. And then we can work to produce an SBOM that analysis tools expect, which is, I think it's super, super powerful. I don't know. So one of the cool things about bomctl is that it's being built in the open as part of the whole, family of projects across the OpenSSF. Do you want to talk about the stack below it, how we ingest it and how we store the data, all of that?
There's that slide.
You want to take that one, John?
Yep, sure. So we have kind of a top to bottom kind of thing would be, so from the top to the bottom of that stack there would be a fetch operation, basically. So inputs being either one of the two popular formats, CycloneDX or SPDX. From there, we serialize that to protobom. So that's, if anyone's not familiar with protobom, that's a protocol buffer's representation of an SBOM document. And this is kind of funny, actually. Like the majority of code that supports bomctl is actually in the protobom storage project. So that uses a Go library called ent in order to define schemas that represent the protobom spec, and then generate code that we can use to store and retrieve SBOMs in our SQLite database. And going back up that stack would be more of a push operation. So we can then export the internal database protobom representation of a document to one of the two popular formats we have on top there.
Yeah, I think that's really.
Okay.
Sorry, I think that's. I mean, really the whole point of protobom, but I think that's one of the things that it helps make bomctl so powerful is that. Your suppliers, your dependencies are going to have SBOMs in any format. You don't control how they generate them. But with bomctl and protobom, you don't care about them. You don't care about what format it's in. You can ingest them in any format, do the modifications if you do linking or whatever else you need to do, and then you can export them in any format or every format, maybe more beneficially. But it's something that kind of takes that conversion out of the equation, takes that extra step of having to go from CycloneDX to SPDX or back and forth, depending on what your supplier gives you or what your customer wants or what you internally use. You don't have to care about that with protobom, and I think that's awesome.
Yeah, like if we were to have to maintain, interpretation, parsing, and writing both formats simultaneously, I'm not sure that bomctl would even be feasible. Having two different forms of expression in the same database schema, that would be really tough to manage. But so I think that protobom is a significant enabler of what we're doing here.
Yeah, and I think when you look at it like this, and I really like this slide that you put together, because when you look at it this way, you can see all of the community efforts coming together. So below protobom, there's the native language libraries that both Cyclone and SPDX are maintaining. On top of it, it's protobom. But then on top of protobom, you're building the ent backend. So this is what I was talking about before. Like, not unless you're a company selling an actual SBOM service or whatever, it may not be something you need to care about. And I think it's wonderful that from an open source perspective that we're all building all of this stack together, so that all of the problems get solved for you, and you can just tap into this, use what I hope it's. I mean, bomctl is. I hope protobom is a high quality software, but people can not have to think about all of this, which is it's amazing. And also notable is that this is like a more of a vertical view, but also if you were to expand this view, other projects across the foundation are also using this. Like we have OpenVector is also using some of these libraries, and also SBOMit, which probably, I don't know, we should also talk about because it's kind of in the sphere of things. But I don't know. So do you want to talk about this? Do you want to go deeper into bomctl? What do you want?
I think there's just two things that I want to add on to this slide that I think maybe delineate and show roles and responsibilities. Like I think in a lot of ways, I tend to think of like bomctl as being a wrapper around protobom, right? There's a fundamental objective, which is to push as much as this, I'll say, a lot of the manipulation of SBOMs should reside in protobom, right? Because I think an easy to use library drives commonality between two different specifications and in tooling, right? So I would love a day when every commercial SBOM vendor uses protobom as the underlying mechanism for manipulating and maybe even generating SBOMs. And I think a lot of times when people first hear about protobom, they wonder, all right, great, how do I run it, right? And as a library, well, you need a front end, right? And what does that front end look like? And bomctl as a CLI is a little bit like the front end of protobom. And so I think it's good to think of them kind of like that distinction. Like bomctl is kind of like a thin wrapper, it's a CLI wrapper around a lot of the functionality built into protobom.
Yeah, it's in actually the project has a strong inclination to get rid of its own tiny CLIs, demos that we built over the years, and instead focus on strengthening bomctl, which is what makes sense.
So you asked about SBOMit, and I think SBOMit is a really it's been a little slow starting, but I think we're beginning to see it pick up as a project. So I think the question that SBOMit is trying to answer, so it's software bill of materials on in toto, so in toto attestations, is how do we make the content of an SBOM like verifiable? Like how do you provide enough evidence that you can be like, yes, like these are the components? I mean, I think anyone who's worked in security long enough has seen someone try to edit a file as a way of mitigating a vulnerability. And I see as SBOMs become more widely adopted, like there will be a day someone or a vendor says, hey, I patched this, and they just delete like a component out of a text file, right, out of your SBOM, and they deliver it and they call it good. Life is great, head in sand. And so a lot of like the work that we talk about around, like, hey, signing with SigStore, right, to show integrity, using in toto attestations to provide a little more of the provenance, like how did we come to the conclusion that we did? SBOMit is trying to marry some of those ideas directly into SBOM documents. So can we take in toto attestations that help really define how something was built and therefore what was included in the build, and actually use that in toto attestations to help verify that an SBOM is complete or correct? That's really what SBOMit is trying to do. It's a specification. So I think the specification is pretty well understood at this point. And now we're kind of going into that adoption phase. Like, how do we begin to get the specification adopted by different tooling? Well, it's great, right? Like, let's build some of that verification directly into protobom or directly into bomctl as a first step, right? Like, building a tool that produces verifiable evidence with no way to verify it is kind of meaningless. So let's build a verification engine first. And then it makes sense for us to go work with a lot of different suppliers. Like, I would love a day when, say, SIFT, for instance, builds an attestation of how it built an SBOM and therefore you can make assertions about how valid a SIFT SBOM is. Same thing for Trivy. And I don't think it doesn't have to be 100% like bulletproof, but if it gives you as an end user levels of assurance of like how complete that SBOM is, there's a lot of value in just knowing, well, how much confidence do I have in my SBOMs, right? Especially as we talk again about like some of the policies coming along with like CRA or what's going on with the US government. People are going to have to be able to judge the quality, I'll say the quality, but the provenance, the completeness of what they're passing along to others. And that's really what SBOM is trying to solve. Sorry, SBOM. SBOMit is trying to solve.
Yeah, I remember about a year ago, maybe 2 years ago, the wonderful crew from the cloud native space called SigHunk, they did this talk called malicious compliance, where they would scan an image and then start poking and removing pieces of the image and moving files around to make sure that scanners were blind or at least misled into the findings inside of the container image. And part of it was the SBOM. So this also ties to the idea for people new to SBOM. We have different types of SBOMs. So you have SBOMs that are built at build time, that like from the information from the build, and also we have like SBOMs that can be built from observing the already built artifact. So an attestation that tells you exactly where it got the information, and it cannot be forged it's one of the missing pieces. And the wonderful thing to see here is that most of the work when you have to deal with the formats themselves and storing all of that information can already take advantage of the other projects that are already going on in the OpenSSF, which is, I don't know, to me, it's like seeing the pieces all fall into place. It's wonderful. Cool. All right. We're getting to the end of our hour, but do you want to talk about something else? Is there something pressing that you want to share with the...
You said something earlier, and I think we talked a little bit about like the Renaissance right now, and I think it's very much what we just talked about. Is that I think the last couple of years there's been a lot of progress on the specifications, like a lot of capabilities were put into the specifications, and I feel like we're now entering a phase where the tooling is going to catch up, and so I think I often hear a lot about how like, oh well, what's the point of SBOMs? I can't really do anything with them right now, right? I can't generate them well enough right now. And I think that is going to shift pretty dramatically over the next, I'll say, year, because the specifications have so much capability built into it. And I feel like the tooling is beginning to catch up. And so like what you can do is going to get exponentially more complex and more interesting from like what you actually achieve out of this over the next year. I don't know if you feel any different. Like we talk a lot about specifications, but like with SPDX 2.0 getting solidified, like there's an immense amount of like implementation that's going to roll out over the next couple months, I feel like, and that's going to like trigger a lot of tool, features that we just have talked a lot about, but now we'll actually begin to use. I don't know, Porco, if you have any thoughts on that, I'd love to hear your thoughts.
Yeah, that's kind of what my views are about the new phase of SBOM. Like we will start seeing tools that can actually look at the SBOMs, handle all of the variances in data well enough so that they can do their job. So right now, tools have been weak because they're used to some flavor, some niche, some particular variant of SBOM. And now that we have more robust tooling, and we're going to start seeing that the SBOM muscle is going to start flexing a lot more, and then we have more robustness across the ecosystem. Yeah, I totally agree. All right, so I think, do you want to share some of the upcoming plans for bomctl and maybe mention how people can get involved with the project?
Sure, sounds good. Oh, I'm going to do it. Is that what we're...
Open your mouth, sorry.
Yeah, I did when that'll teach me. Yeah, so in work right now is mostly a lot of discussions about what is this going to look like, because the big thing on our plate is SBOM linking. So we need to have discussions about reconciling one spec or the other. How do they manage external referencing from document to document and from a node or component or package to a document? So we're still working through some of those details and putting a lot of the pieces in place, particularly on the SQLite backend that will enable that kind of stuff. Also just wrapped up on the initial implementation of a bomctl GitHub action, which may or not be super production ready yet, but it's there if people want to test drive it and let us know how well it works. It's got a little bit of extended functionality beyond what bomctl does, and that is so basically it'll install bomctl in your GitHub workflow. It'll run a command and some arguments, and then you have the option at the end to export the contents of the resulting database to a SQL script or just like a raw JSON dump. I won't pitch that too much because I wouldn't say it's, like I said, super production ready, but it's there. What else do we have on our plate? Alan, do you want to talk about anything else that we have coming up?
We can talk a little bit about the roadmap. One of the other things we have in the works is retrieving and storing SBOMs without modifications. So there's a lot of times where there's a signature attached to an SBOM and you want to make sure you don't lose that in transit. And that's something that there's a PR open for. That's something that we are really concerned about. Obviously, we want to make sure the tools that sign SBOMs, and we want to be able to sign them eventually and provide that signing. And we want to make sure it's not lost in transit if you don't want it to be. And that's another thing real quick. And then beyond that, we're going to be looking to integrate with some commercial SBOM registries. We have a GitHub and GitLab client in the works, so you'll be able to utilize their API endpoints, and I guess we will, and you'll be able to take advantage of that. But also in the future, we'd love to get more involved with these commercial businesses that are offering these SBOM registry platforms and SBOM registry tool chains that we can kind of leverage and make everyone's workflow a lot easier.
Yeah, absolutely.
I think two other items to throw in there also is like, as the bombs move through bomctl or other systems, right? Like, how do we keep that provenance flowing through it? So be it within total attestations or some other mechanism, how do we ensure that like we've received these bombs, we've built this tree, or we've manipulated something like that there's transparency in that. The other end of it is, I'll say, redaction, right? And I think there's, I've heard some really interesting work from Santiago Torres out of Purdue, out of Toto fame.
Previous guest of the show.
Excellent. Yeah. So, you know, I think he has some students that are working on SBOM redaction, where they're doing like cryptographic redaction of SBOMs, which I think is really interesting to me, where maybe you have an SBOM, parts of it are encrypted, and you have some sort of RBAC-like policy where you can say, oh, you're an end user, you're in security, you need the entire thing. Or you're in compliance and you only need the license information. Like, how do you begin to handle that? Because there's definitely, like we talked about supply chains, right? Like there may be say like my employer, there might be a supplier in our supply chain who doesn't want to give us all the details, right? And this is one of those areas we often hear pushback on SBOMs, is on like secret sauce, like, oh, we need to sign an NDA and we're gonna make it really hard for you to actually get anything. Like, how do we get over that? So I think that's super cool. And then I'll speak to the last one. I think clearly a shout out to the protobom community, which I think meets on Wednesdays. Is that right?
Yeah, Wednesday, every other Wednesday.
Nice. And then the bomctl community meets every Monday at 2 p.m. Eastern. 2 p.m. Pacific. Yeah, it's like, you know, we're always looking for new folks to get involved. And we try to mark some issues as good first issues and do all those best practices. We can be found on bomctl on the OpenSSF Slack.
Amazing.
Awesome.
Yeah, perfect. Because we're at the hour, and it's I don't know. It's been a wonderful conversation. I could, as you know, nerd out about this stuff for weeks, months, whatever. But I don't know. So thank you, Ian, Jonathan, and I mean, it's very interesting to talk because we interact almost every day. Building all of these sorts of problems, but it's important to also get it in front of other people, and maybe attracting the attention of others that want to share ideas around this stuff.
Yeah, thank you so much. It was super great.
Thrilled to be
Yeah,
here.
man.
Thanks.
Yeah.
thank you.
All right.
Catch you.
Well, have a great. Yeah. Sweet. Have a great night.
All right, you too.
Take care,
Thanks.
everybody.
See you guys.
Bye bye.